Welcome pre-calculus to your first lesson. We are going over Module 1, Lesson 1, and this is going to go over sections 1.3 and 3.1. The good thing about these videos, you may not be able to ask me questions the way you would in class, but what you can do is pause this video and rewind it as many times as you need to. If you think you have a concept, I encourage you to pause the video, try to solve the problem ahead. Play the video, check if you got it right. If you got it wrong, figure out where. If I go too fast on something, pause it and rewind it and watch it again and again until you understand it. In this lesson, we're going to go over linear equations and linear functions. They really are just about the same thing with one exception. In both of these, we need to go over slope. And another word or term for slope that you will see is average or consistent rate of change. So all three of those mean the same thing. If it asks for slope, average rate of change, or constant rate of change, it's talking all about the exact same thing. Now, for all of these terms, we have a couple different ways that we write our slope formula, but really they mean the same thing as well. We have delta y over delta x. If you are specifically an engineer major, that's going to go on to calculus, DiffEq, and on. You need to be familiar with delta y over delta x. Delta just means the change. And so because delta means change, we can also write that as y2 minus y1 over x2 minus x1. And when we're dealing with it on a graph, we will use rise over run. Now with slope and functions, we have three different types of slopes. If it is going from left to right, it is going up. We call this an increasing slope, and these are always your positive slopes. From left to right, if it's going down, this is then decreasing, and these will be negative slopes. And then the other thing that can occur is you have a horizontal line. This is considered not increasing, not decreasing, but it is constant. And this is whenever you have a zero slope. So in example 1, it asks us to find the slope slash average rate of change. Again, if they said constant rate of change, same thing. And then we need to determine whether the linear function is increasing, decreasing, or constant. So in this first one, because it's a graph, we're going to use our rise over run. So let me zoom in here. And so you want to find a spot on this line where it is crossing this coordinate exactly in the middle. And we have 3 points for that. We have one here, we have one here, and we have one here. Technically, we would have one here as well, but you can't really tell since the graph's ending, but we do have one there. So now that we have found, you need at least 2 points. We are going to use slope equals rise over run. And so starting at 1 point, I'm going to start at this one here. I want to count up how many units we are going up. And in this case, I'm going up 1, 2. So that's my rise. And notice I put a plus. Those do matter. So we're going up a positive direction of 2. And then my run is 1, 2, 3. But because we are now going in the negative direction towards the left, we are running a -3. So you would look at these numbers afterwards. Can you reduce them? And the answer is no. So that is our final answer. It doesn't matter which of these 2 points you pick, you get the same answer no matter what. If I go from the middle one to the top one, you're going up 1, 2, you're running 1, 2, 3. If you go from the bottom point to the top one, you get the same answer, but you have to reduce first. So let me show you that. If you do that one, you go up 1, 2, 3, 4, and then you would run 1, 2, 3, 4, 5, 6 in the negative direction. And so you'd get 4/6, -6, which reduces to, again, -2/3. So it does not matter which of these points that you pick. On example B, now we're given 2 points. When I'm given 2 points, I'm going to use this formula here. So label your points. You have x1, y1, x2, y2. Doesn't matter which point gets the 1s, which one gets the 2s, as long as the 1s are together and the 2s are together, and it's always x, y. So my slope formula is y2 minus y1 over x2 minus x1. I recommend writing your formula every time. You're going to have to memorize these. And so the more times you write it, the easier it's going to be to memorize it. So now I have my formula. I have my points labeled. So now it's just plugging in. My y2 is 3 minus y1. My y1 is a -2. So we got minus a -2. The first negative is in the formula. The second negative is what my y1 is. All over x2, x2 is 5, minus x1, and x1 is -1. So same thing, minus a -1. The first negative is in the formula. The second negative is what my value is. So we can clean that up a little bit. 3 minus a -2 is a plus. 5 minus a -1 is also a plus. So my final answer, my slope, is 5/6. Now we're supposed to be saying if this is increasing, decreasing, or constant. You could plot these points if you wanted to, and you could see that it's going up, but because I know my slope is positive, that does mean that this one is increasing. So if I go back to my first problem, I can see here that my answer is negative. Before even finding that slope, I can see that this line is going down when you go left to right. So this one is decreasing. Okay, and then lastly here, you're given a table. Now, when you're given a table like this, you can do the same thing that we just did here on B. You could say, here's my x1, y1, pick another point. This one's my x2, my y2, and use your formula here. The easiest thing to do, though, whenever you get a table, is to use your delta y over your delta x. That just means the change in. So when I'm looking at my y values, how are they changing? Well, from 4 to 1, we subtract 3. And so before I write my delta y as a minus 3, you kind of want to check to make sure that this is jumping at the same rate. So from 1 to negative 2, that's a minus 3. Negative 2 to negative 5 is another negative 3. And negative 5 to negative 8 is negative 3. You do want to make sure that it is constant, and when they are constant, that is what makes it a line. If these start getting different, then your values are going to get different. You're going to have parabolas, you're going to have cubics, you're going to have some kind of up and down kind of movement. But when these are the same, that's what makes it be a straight line in one way or the other. Okay, so then look at your delta x. How is this changing from one number to the next? Negative 2 to negative 1, we're adding 1. Negative 1 to 0, adding 1. 0 to 1, adding 1. And 1 to 2, adding 1. So my delta x is 1. So my slope here is negative 3 over 1, or just simply negative 3. Okay, and then again, because this is a negative slope, that means that my line is decreasing from left to right. Now we have two equations. You have slope-intercept form of an equation of a line, and then a linear function. These are truly the same thing. It's just notation. Slope-intercept form of a line is y equals mx plus b, where your m represents the slope, and your b is your y-intercept. And your y-intercept can be written in the form of 0, b, b being a number. So then your linear function is f of x equals mx plus b. So what's the only difference here? The only difference is here you have y equals, now we have f of x equals. Notation. Y and f of x are the same thing. So we need to keep that in mind. Because of that, that means this is the same thing. Your m is your slope, and your b is your y-intercept, which is again in the form 0b. So example 2, determine the slope and the y-intercept of the linear function g of x equals negative 3x plus 1, and then graph. So this is already in this form here. So my slope is what's in front of the x. So my slope is negative 1. And because I'm graphing, I really want that in a fraction form, so I know rise over run. And so I'm going to make that negative 3 over 1. And then my y-intercept is whatever's not with x. In this case, 1, so 0, 1. Whenever we graph, we're always going to start with whatever our y-intercept is. So I'll start right here. And then use your slope to find more points. So -3/1 means I'm going to go down 1, 2, 3, and then this is a positive 1, so I'm going to go in the positive direction of 1. And you can do that as many times as you want. I recommend 3, but 2 is really all you need because you can draw that line right there through it. But I would go down another 1, 2, 3 and run 1. You can do the whole page if you want to. Now with these, sometimes you can't go in one direction, and so it's good to know how to move in the other. -3/1 is the same as +3/-1. It doesn't matter where that negative is, as long as you have one on top or one on bottom. What you cannot have is -3/-1, because negative over negative is positive. So if I use this, that means my rise is positive, so I'm going to go up 1, 2, 3, and then run now a -1 to the left. 1, 2, 3, run 1, 1, 2, 3, run 1. And so now there's my line. And is this slope increasing, decreasing, or staying the constant? Well, I can see right here it's negative, or I can look at my graph that it's going down, so this is decreasing. Example 2, find the slope and the y-intercept of the line 2x minus 5y equals 10. This one, unlike my first one, is not in this form where y or f of x is solved for. So I need to take this equation here, 2x minus 5y equals 10, and solve this for y. So I'm going to move my 2x over, and the opposite of a positive 2x is a negative 2x, so that cancels. I'm left with -5y equals, we cannot combine these. And because I want this, in this form here where my x is first, I'm going to put -2x plus 10. Just make sure my 2x is negative here, so it needs to be negative here, and my 10 is positive, so it's positive here. Keep the signs, whatever it is. And then lastly, I'm going to divide by -5. Instead of just putting this all over -5 like this, I recommend putting each term individually over it, so you'll remember to divide everything by what you're dividing by. So I've got -2x divided by -5. Negative over negative is positive. So I have 2/5 x. And then 10 divided by -5 is a -2. So now that I have this in my form I need, now I can say what my slope is and what my y-intercept is. So my slope is what's with the x. So we've got 2/5. Okay, and then my y-intercept is what's not with the x, so it's this -2. So I've got 0, -2. Again, whenever you're graphing, you always start with the x-intercept. So I'm going to start at -2, and then my slope is 2/5, so it means I'm going up 2 running a positive 5. So from this point, I'm going up 1, 2, running 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5. That's definitely enough points, but again, in case we needed to go the other way, this is the same as negative 2 over negative 5. Negative over negative is positive. So that means I can go down 2 and run a negative 5. So I'd go down 1, 2, run 1, 2, 3, 4, 5. Run down 2, or rise down 2. Run 1, 2, 3, 4, 5. Now, of course, when you're graphing, you're not going to have all those dots in between. I just have those dots so you can see the movement that I'm taking. So yours should not have these dots. Okay. And is the slope increasing, decreasing, or constant? You can see here that my slope is positive, or you can see here that my line is going up, so it is increasing. Example 3, here's a little real world problem. It says the annual fixed cost of owning a small sedan is $4,252, assuming the car is completely paid for. Goodness. The cost to not dive the car, but probably drive the car, is approximately 14 cents per mile. Write a linear equation that relates to the cost C and the number X of miles driven annually. What is the cost of driving 4,000 annual miles in a given year? So first, we just need to write a linear equation. So here, we're trying to find that equation as it relates to the cost. So my cost equals, well, it says the annual fixed cost of owning a small sedan is $42.52. And it says the cost, again, to drive, not dive, the car is approximately 14 cents per mile. That per means that we are multiplying, so 14 cents per mile in miles equals X. So that is plus 0.14x. Now, if we were to write this in y equals mx plus b form, we would really want this as c equals 0.14x plus 42.52. The first answer is great as well. They really mean the same thing. So the second part of this is, what is the cost of driving 4,000 miles in a given year? So what does this 4,000 represent? Does it represent the C, the cost, or X, the miles? It says driving 4,000 annual miles. So they're telling us that X equals 4,000. So plug that into your X here. So my cost equals 0.14 times 4,000 plus 42.52. Okay. I'm sorry, that's going to bother me. Let me rewrite that. Okay. So then that's just calculator work. Plug that into your calculator and you should get 4812. So if we had more room, we would write that out. Word problems need word answers. So because I don't have room to write that out, what does this mean in relation to my problem? It means if we drive 4,000 miles, then the cost of any given year is going to actually cost me $4,812. We need to know another equation, and that is a point-slope form. So our point-slope form is y minus y1 equals m times x minus x1. So this still equals my slope, and then x1, y1 is a point x1, y1. I should have talked about this earlier, but the way that these equations are named is exactly what you are given or exactly what you need to use it. This is called point-slope form. Why is it called point-slope form? Because we need a point and a slope. So point-slope form, you're using point and a slope. Up here, this was called slope-intercept form. Why? Because we found the slope and the y-intercept. So these are named, not creatively at all. They're named by what they give you or what you need in order to use them. Example 4 says, find an equation for the line with the given properties. Express your answer either in general form. General form is ax plus by equals c. We will never, I don't want to say we'll never use it, but I'm not going to use it. Or slope-intercept form, and slope-intercept form is y equals mx plus b, because it gives you the slope here and the y-intercept here. So basically, solve for y. Okay, so A, we have slope of 3, so that's our m, containing points 2 and negative 4, so that's our x1 and our y1. So I'm going to rewrite this formula because I know the more times I write it, the better I am at memorizing it. So I have y minus y1 equals m times x minus x1. So y minus my y1 is negative 4. So minus a negative is actually going to be a plus 4 here. Kind of skipping a step. Okay, but if it's minus a negative 4, I know minus a negative 4 is a positive 4. My m is 3. And x minus x1, my x1 is 2. So solve this for y, and in order to solve this for y, we're going to do distributive property first. So y plus 4 equals 3x minus 6, and then subtract your 4. So I get 3x minus 10. Now this gave me everything I needed to use point-slope form. On B, we need to find the equation containing these 2 points. So I am missing my slope. Lucky for us, we know how to find the slope between 2 points. That is y2 minus y1 over x2 minus x1. So we have x1, y1, x2, y2. So y2 is 3 minus y1 is 5. x2 is negative 3 minus x1, which is negative 4. So that's going to be plus 4. So I'm going to get negative 2 on the top over 1. So that's negative 2. Now I have a point, and now I have a slope. Now I can use my point-slope formula. So y minus y1 equals m times x minus x1. Not only do I have 1 point, I have 2 points. I am personally going to use x1, y1 because that's how my formula is labeled. So I'm just going to use that. But if you use the second point instead, you get the exact same answer. So if you want to pause the video and use this point for your x1, y1, you can see if you get the same answer as me. But if you want to follow along, then we'll have y minus y1, which is 5. My slope, we just found out to be -2. And then x minus my x1 is -4, so again that becomes +4. Distribute your -2. Y minus 5 equals -2x minus 8. Add your 5. And we get y equals -2x minus 3. Now with C, we could do the same thing that we just did here. I could find my 2 points, and it looks like we have a point here, and we have a point here. I almost said here, but that's not quite perfect. So we could say that this point here is 0, 4. This point here is -4, -3. We could find our slope and then put it into point slope form. But don't work harder, work smarter. If these are my 2 points, use rise over run. So I am rising from this point, 1, 2, 3, 4, 5, 6, 7. And I am running 1, 2, 3, 4, both in a positive direction. I have my y-intercept. My y-intercept is where this graph crosses at the y-axis, which is right here. So my y-intercept is 0, 4. So now we can put it into our y equals mx plus b form because I have both of those answers. My slope is 7/4 and my y-intercept is 4. Same thing with D. I could say this is my x1, y1, this is my x2, y2. Find the slope, then put it in point slope. But we also know that slope equals delta y over delta x. So how am I going on this side here, on my y? From 8 to 11, we're adding 3, 11 to 14, adding 3, 14 to 17, adding 3. Delta y is 3. How are we moving on this side? From 0 to 1, adding 1, 1 to 2, adding 1, 2 to 3, adding 1. My delta x is 1, so my slope is 3. Again, lucky for us in this table, we are given our y-intercept. Our y-intercept is always 0, b. right? That's what we listed right up here, 0b, 0b. So you're looking for something with the x of being 0. So this right here is my y-intercept. Specifically, the 8. So now my y equals mx plus b. I don't have room to write it, so I'm not going to write my formula. But my y equals mx plus b. My m is 3. And my b is 8. On the last page here, we have an equation for a horizontal line. That is just simply y equals b. If it's a function instead of an equation, what's another way to write y? Another way to write y is f of x. So f of x equals b. These are essentially the same thing. So it says for the linear function f of x equals 4, determine the following and then graph. This is almost easier to graph and then answer the questions. So I'm going to graph first. So if it's f of, what is it? F of x equals 4. On your y-axis, you're going up 1, 2, 3, 1, 2, 3, 4. And it's this horizontal line right here. This is really messing up, sorry. Okay. So 1, 2, 3, 4. Okay, so that's my line. So what is my slope if it's not going up and if it's not going down, if it's staying the same, it is 0. What is the average rate of change? These two things here are the same, so it's 0 as well. My y-intercept, where is it crossing this y-axis at here? At 0, 4. Is this increasing, decreasing, or constant? Horizontal is always constant. And the last portion of this lesson is parallel and perpendicular lines. Your symbol for parallel are two lines right next to each other, because that's exactly what parallel lines are. Parallel lines, because these lines are just perfectly together, it means these slopes, when you rise and you run, they have to be the same. So parallel lines have the same slope. Perpendicular lines, okay, and that's your symbol for perpendicular, because perpendicular lines make 90-degree angles. So it looks like a 90-degree angle. Perpendicular lines, these have slopes, or we'll just say slopes are opposite reciprocals. So what I mean by opposite is opposite signs. One's positive, one's negative. And reciprocals means you're flipping the fraction. So for example, two-thirds and negative two-thirds. One is positive, one is negative, and then we're flipping that fraction. Another example would be negative 1/5. The opposite would be positive 5, because that'd be positive 5 over 1. So positive 5. So example 6, find the equation of a line that is ... parallel to the line y equals 5x and contains the points 2 and negative 3. So in this equation here, my slope is 5. So my parallel slope, these have the same slope, so my parallel slope is also 5. So now I have a slope and I have a point. I'm using point slope formula. Point slope formula is y minus y1 equals m times x minus x1. So y minus, this is x1, y1, so y minus my y1's negative 3, so this is y plus 3, equals, my slope is 5, x minus x1, which is 2. So distributive property makes this 5x minus 10. Subtract your 3. And we get y equals 5x minus 13. B is the same thing, but now we're looking for perpendicular. So perpendicular to the line, y equals negative 3x and contains the point negative 7, 0. So my slope here is negative 3. So my perpendicular slope is opposite reciprocal. So if this one is negative minus positive and flip the fraction, this is 3 over 1. So this becomes 1/3. So now we're going to use y minus y1 equals m times x minus x1 because I have a slope and I have a point. This is x1, y1. So I have y minus y1, which is 0, equals my slope, which is 1/3, x minus x1, which is 7, so that's going to be a plus 7. Y minus nothing is just y. Distribute your 1/3, we get 1/3 x plus 7/3. All right, that's your first lesson. Please pause this and rewind it as much as you need to. And if you have any questions, please feel free to email me. See you guys next time. Bye.